What's up, guys, and welcome back. We're going to begin our Unit 8 talking about right triangle trig. And without further ado, let's get started. Before the break, if you recall, we talked about how to construct reference triangles to find reference angles. And today we're going to use this information to find segment lengths, ordered pairs, and angle measurements of right triangles. Just to kind of recap, right triangles have a 90-degree angle. Pythagorean theorem is a useful way that if we know two sides of a right triangle, we can find the third side. And then when we do use Pythagorean theorem, if we do, we need to make sure that these letters just represent sides, right? I can call those X, Y, and Z. A, B, C, whatever, but we're typically associate Pythagorean theorem with a squared plus b squared equals c squared. The main catch here is that whatever c squared is, whether that's z squared or m squared or whatever you write there, that has to be the hypotenuse. So this is the hypotenuse side. The other two sides don't matter what order you write them in or whatnot. Here we have our first example. We're going to draw a reference triangle. So we have a terminal side in quadrant 1. And if any of you guys recall from the semester exam, you had a problem that was kind of like this that we had originally had during the first semester, and we pushed it till after the semester. So we'll talk about how to do that today. But we're going to practice drawing a reference triangle, then finding some of these side lengths and being able to identify these. So if I have a point at 3, 6, and I want to find OP, so the distance between the origin and that point on the terminal side, we're given that point is 3, 6. Well, remember the 3 is my X and the 6 is my Y, so that is said from the origin, I have moved to the right 3 and I've moved up 6. That's where I get that point. So now when I think about that in terms of distance of a triangle, like that leg right there is just 3 units long, and that one's 6 units long. So if I have two sides of this triangle and I'm trying to find OP, I can find the hypotenuse. O is always going to be the center. OP will always be our hypotenuse. Okay, there we go. And so I can set this up as so. So my hypotenuse is the OP. Once again, I'm not calling that c squared. You can if you want. But now I have 3 squared plus 6 squared, which is 9 plus 36. And that gives me 45. And I need to square root that to get the OP by itself. And I'm going to write this as a decimal right now, so approximately 6.71. Technically, and we are going to be talking about simplifying square roots, this is called an approximate answer because we have rounded that. An exact answer would be to leave the square root, but always, just like in anything in math, we would want to simplify. So I'm fine with the purpose of this first example and stuff, writing like this. The square root of 45, if you guys recall from Algebra 2, the way I like to think about how this simplifies is see if there's a perfect square that divides that number inside the radical. So perfect squares are things such as 1, 4, 9, 16, 25, 36, 49, ... so on and so forth. So in other words, you take the square root of any of those and you know what that thing is. It's a nice whole number that we know. The square root of 3 is not a whole number. The square root of 2 is not a whole number. The square root of 6 and 5 and 7. So, but all of these, if I take the square root of those numbers that I'm erasing right now, that gives me a nice number. So I would say, is there a perfect square that can divide 45? And it turns out there is. 9 is a perfect square, so I'm going to rewrite this. So so whatever I write this at, if I multiply it back out, it will get me what I started with, right? So the reason why I chose 9 and 5 is because 9 times 5 is 45. And when I do this, I'm looking at the one that is a perfect square, and then I'm going to rewrite that. So the square root of 9 we know is 3. And the square root of 5, we don't know what that is, so we leave that as that. And this is how that simplifies. So 3 square roots of 5 would be considered an exact answer. 6.71 would be the approximate answer. So I would have you guys try this and do the same thing. We're trying to find side OP. Now, the difference here, if you're trying this for the first time, is that notice our point is negative. But if we're talking about a triangle and a length of a triangle, like on that leg, like when we're looking at the triangle's lengths, we don't have negative, so this is why I put positive. Of course, it wouldn't matter anyway if you put negative down there, because we're going to be squaring it, and that's going to turn out positive. But in the end, we should get something like this, same type of problem, and then that should be 5. Okay, so that was in quadrant 2. Failed to mention that, so that's in quadrant 2. Now we go from quadrant 3, and remember when we rotate around the from the starting position along the positive x-axis, I'm rotating counterclockwise to get this point. So I'm going to draw a reference triangle. Reference triangles are taken from the point on the terminal side to the x-axis always, and then I'm going to label what I can. So I'm given the y value here of -5. So what would that be on this triangle? And I'm also given the OP, which is my hypotenuse, and I'm trying to find x. So I'm going to label this a +5 because that's the length. The ordered pair would be negative for sure. And then I'm trying to find x. So that OP I'm also given is 6. So now when I set this up, 6 is on the other side of the equal sign. And then if I square 5 and then subtract that from the 36, I get 11. The square root of 11 can't simplify. I'm going to write that it's a decimal. Put that into my calculator. We must consider what quadrant we are in when determining the sign of the x and y values. That's a good point. I'm glad I reminded myself of that. Because when I ask you find x, I'm not, yes, x is representing the length of this side, but I'm talking about the ordered pair of x. So here we have to understand that, like right down here, I'm asking you to find that. So we know that x is going to be negative. So because we're on the left side of the y-axis where the x values are negative, so I'm going to make that like the square root of 11 is 3.32 approximately, but I'm going to write that as negative. And we do need to be aware of that as we're going through and working through some of these. I'm going to have y'all try the same thing. Now we're in quadrant 4. So what is negative here? Y is negative. So we were asked to find y. So if our answer is not negative to begin with, we need to make it negative because we're in quadrant 4. So we're going to draw a reference triangle, label what we can. Our hypotenuse is 10. Our x value is 7. And I'm going to set this up. Do the same thing we just got done doing. Square 7, square 10. I'm going to subtract 49 from both sides and get the square root of 51. But we are going to have a negative y value when we're done. So the square root of 51 is 7.14 approximately, but I'm going to make that negative because I'm asked to find the y. Okay. So that was looking at a point on a terminal side, determining sides and side lengths of triangles, things of that nature. Now we're going to review something called SOHCAHTOA. So on a right triangle, trig ratios, our hypotenuse is always the opposite of the 90-degree angle. And as I'm writing this out, I want you to notice this right here, this angle represents the angle that I'm referencing. So, and we can call that theta. But when I write my hypotenuse is always opposite of the 90-degree angle. So the 90-degree angle in this case would be like right here. So it's always opposite of the 90-degree angle, but the opposite and adjacent side are with respect to the angle that I'm referencing. So notice if the angle is right here, the side opposite of that angle would be this side of this triangle. And then the adjacent side is going to be like, it's going to be joining with, it's going to be one of the legs that are on the angle I'm trying to find. It's not the hypotenuse and not the opposite side. So the SO in SOHCAHTOA, the S stands for the sign, and this is just a way to help remember it, and the OH stands for the opposite and the hypotenuse. So the ratio that we can use here, and we can use this to find sides and angles of right triangles only, is sine of our angle equals the opposite side over the hypotenuse side. And then cosine, the C for cosine, A for adjacent, H for hypotenuse, similar, just using the adjacent side. And then tangent is the opposite over the adjacent side. If I have, kind of going back to, what if my angle was right here? So same triangle, but I want this angle. Well, then this would be that's still my hypotenuse. This would be my opposite side because that is opposite of the given angle. And this would be my adjacent side. But the SOHCAHTOA doesn't change. It's just depending on what it is I'm trying to find. So sine's still opposite over hypotenuse, cosine's adjacent over hypotenuse. It's just depending on the angle in question in terms of what I'm calling opposite and what I'm calling adjacent. So let's look at this problem. Given a point given a point 512 on the terminal side of theta, and an angle in standard position, write the trig ratios for the sine, cosine, and tangent of theta. So I'm going to simply just put this point on the graph and start by determining what quadrant. If both x and y are both positive, I should be in quadrant 1. Then I'm going to construct a right triangle on the terminal side in standard position, meaning I'm going to draw some type of ray coming from the origin in quadrant 1, extending out, and at the end of that, that's going to be my point 512. So I'm going to go over 5 on the x-axis and up 12 on the y-axis to get this point right here. And now I'm going to write my trig ratios. So, well, actually, I'm going to label the sides. So that would be 5 and that would be 12. So now my angle and the angles that we're going to be using are always going to be these angles. These are reference angles between the x-axis and our terminal side. So the angle that I have labeled here, theta. And I'm going to write my trig ratios. But before I do that, I need to find my third side because the hypotenuse. So 5 squared plus 12 squared gives me 169. If I take the square root of that, that gives me 13. I'm going to go ahead and label that 13, and then I'm going to set up my trig ratios. So using SOHCAHTOA, my sine is opposite over the hypotenuse. So the opposite of the angle, the side opposite of the angle, if I go to the opposite side of that, that's 12. The hypotenuse is 13. That's where that's coming from. Cosine is adjacent over hypotenuse, so the non-opposite side and the non-hypotenuse side would be 5. Over the hypotenuse is 13, and then tangent is the opposite over adjacent. So that's just practicing trig ratios. Given a point -2, 4 on the terminal side, an angle in standard position, write the trig ratios again. So let's go ahead and try this one more time. So I'm going to determine what quadrant I'm in. If x is negative, so if I go over to -2 and up 4, that would put me in quadrant 2. And then I'm going to construct a right triangle somewhere in there. I'm going to label my triangle 2 and 4, and I'm going to once again use Pythagorean theorem to find my hypotenuse. I'm going to go ahead and leave this as the square root of 20. And now I'm going to write my trig ratios. So here we have a situation where you may or may not remember this, but we don't typically leave radicals in the denominator. We want to rationalize the denominator, which means we want to get rid of that. And the way we do that is whatever our square root is in the denominator, we just multiply by that thing in the top and the bottom, because that will cancel, because the square root times itself gets rid of the square root. So and I'm going to do it over itself, so I'm not changing the value of it, because if I do, like when I do the square root of 20, when I do multiply by the square root of 20 over square root of 20, that's really just multiplying by 1, which doesn't change the value of 4 over the square roots of 20, but it allows me to cancel the square root in the denominator. And when I multiply square roots, I can only multiply the square roots together and the things on the outside of the square root. So 4 square roots of 20, it's just 4 square roots of 20. And this would be what my sine ratio is. Opposite of the angle, so 4 is the opposite of that angle, angle theta, and then square root of 20 is my hypotenuse. So the ratio simplified and everything without a square root in the denominator is 4 square roots of 20 over 20, which can also reduce, because 4 and 20 can reduce. 4 divided by 20 is just 1 over 5. So that's the square root of 20 over 5. So this is just, yes, we're learning new stuff, and we're reviewing, or we actually haven't learned new stuff yet, but we're reviewing some stuff, and also how to simplify and dealing with radicals. It can be a lot sometimes, but we're going to do the same thing here with the cosine. Cosine's adjacent. My adjacent side is 2. My hypotenuse is square root of 20. I want to rationalize that denominator by multiplying by the square root of 20 over the square root of 20, and I get 2 square roots of 20 over 20. The 2 and the 20 can reduce to just 1 over 10, and so that would be how I'd express my side or my cosine ratio. Tangent is opposite over adjacent, so 4 over 2 is just 2. That was easy. Okay, so now we're going to use trig ratios to find ordered pairs and angles. So that was just kind of practice setting up the ratios. Now we're actually going to see what it's useful for. We're going to start by determining what quadrant this is in. If I'm given an angle of 70 degrees, we know that that's in quadrant 1. So that's going to be in quadrant 1. I'm going to go ahead and start making my right triangle in the quadrant that I said it was in. So it's going to look something like this. And then I'm going to fill in my information. So I'm given an x value of 3, an angle of 7, and I'm trying to find y. So with respect to this angle, what two sides do I have labeled? I have the opposite of that angle and the adjacent side of that angle. So there's the opposite and the adjacent. So which one of these trig ratios do I use? Tangent is opposite and adjacent in it, so I'm going to set this up. Tangent of my angle that I'm given, 70 degrees, equals y over 3, and then we just solve for a variable like we normally would. To get rid of the 3 in the denominator, since y is being divided by it, I'm going to multiply both sides by 3, and I put that number in front of the tangent, not in front of the 70. For the angle, and then I just type into my calculator 3 tangent of 70. Those are going to cancel, and I need to make sure that my calculator is in degree mode, and when I do, I should get 8.24 approximately. Same thing here. I'm going to have you, I would have you guys try this in class, but we want to find the x value of our point. We're given the hypotenuse here, and we're given 38 degrees, which is also in quadrant 1. So I'm going to start by putting my triangle in quadrant 1, labeling what I can, fill in the information I'm given, the hypotenuse, and the angle. And I am trying to find the x value. So the x value with respect to this angle is the adjacent side, and the hypotenuse is the 20. So I'm going to look at which one of those trig ratios deal with adjacent and hypotenuse, which would be cosine. I'm going to set this up. Cosine of 38 degrees equals x over 20. I'm going to multiply both sides by 20 to cancel that. Type in 20 times cosine of 38. Make sure I'm in degree mode, and I get approximately 15.76. All right, here we're going to start by same thing. Determine what quadrant. If I go over 6 and up 6, that puts me in quadrant 1. Here I'm finding the angle. So we'll see what this looks like here in a second. So I'm going to label my side 6 here, 6 here. I don't really need to do Pythagorean theorem here to find the hypotenuse, because if I'm trying to find the angle, look at what sides I have labeled. I have the opposite and adjacent side. So I can use tangent, and I don't have an angle. That's what I'm trying to find. So this is different than x and y. And I get tangent of theta equals 1. So here's where we have to kind of talk about. Okay, so here we have the tangent of theta equals 1, and I want to solve for this angle. So I want to get just this by itself. So I need to get rid of this tangent, and this is not tangent times this angle. This is the tangent of that angle. So kind of like when we looked at logs and exponentials, they had this weird way to undo each other. So I'm going to talk about that just real briefly. And I'm going to kind of review something real quick. So here, when we first learned how to do things like undoing, like solving for x here, like depending on what the function is, we would do that inverse operation. So in addition, on the first one on the left, I would subtract 7 from both sides because I'm adding 7. I want to undo that, and addition and subtraction are opposites. The next one, subtraction, I would add because that's the opposite of addition. If I'm trying to get rid of the square, then I would take the square root. And if I'm trying to get the square root, I would square. Why? Because those are opposites. When I took the log, when I had a log equation, I would exponentiate. And when I had an exponential, I would take the log of it because those are opposites. So the opposite of a trig function is the inverse. And there's a button on your calculator that's basically, if you know where the sine button is, you just hit second sine. and you should see sine to the -1, and that's what it looks like. So so in other words, this is what the inverse looks like to undo that sign. And you don't have to write this every time, but I'm showing you, because when you write it out algebraically, something's going to cancel. So I'm showing you the left side, the sine of -1 times sine of theta. That's going to cancel those things. But when I'm writing this down, I'm only going to write the right side, like the sine of inverse sine of 1. And that's going to cancel these, and now theta is by itself, so I have something I can type into my calculator, the inverse sine of 1, and I get 90 degrees. We can go ahead and do the same thing for these other problems, write the trig, do the inverse operation. So if I'm trying to solve for theta, do the inverse of both sides, type in what is left into our calculator, and second cosine of 1/2, and get 60 degrees. The problem that we were doing was the tangent of theta equals 1, so I'm going to do the inverse tangent of both sides, cancel the tangent, and then type in the inverse tangent of 1 into my calculator, and I should get 45 degrees if I'm in degree mode. So going back to this, we just did that. That would give us 45 degrees. And we should note that when two sides of a triangle are the same, that's a 45, 45, 90 triangle. All right, let's look at one more, quadrant 3. 220 degrees is in quadrant 3, so I'm going to go write my triangle here, and also I need to take into account that from here all the way to here is 220 degrees, but my angle that I needs to be a reference angle between 0 and 90, so it needs to be 40 degrees. So how do I figure that out again? From before the break, we would ask ourselves, how far away from the x-axis is 220 degrees? It's 40 degrees away, and that gives us that that angle that we need, that we're going to be using a lot. So I have this labeled. I'm given my y value, and I'm asked to find the hypotenuse. So what two sides do I have with respect to that angle? I have the opposite in the hypotenuse side. So that would be sine. I'm going to set this up. This one's going to look slightly different because what I'm looking for is in my denominator. So I first want to get rid of my fraction. So I'm going to start by multiplying both sides by OP, and I'm going to get that. So I'm going to rewrite this as OP times sine of 40 equals 12. And now I want to divide both sides by sine of 40 to get OP by itself. And that cancels those, and now OP is by itself. And once that's by itself, I can use my calculator. 12 divided by sine of 40, and I get approximately 18.67. All right, and that is day 1. So good luck. Complete problems on your worksheet 8.1.